Hello everyone, this is Mrs. Logus and welcome to section 1.8a, which is about modeling with linear equations. Now the last video 1.7 was about modeling systems of equations specifically, but today our goals are to re-look at useful vocabulary for modeling that you've probably learned in your Algebra 1 classes previously. We want to write linear expressions from verbal descriptions or word problems. And we also want to write and solve mathematical models or equations also from word problems or verbal descriptions. So let's get started with some vocab, shall we? First, I'm going to be pausing a lot in this video because I feel like a lot of this material you do have a good gut instinct on. So, what is the difference to you between simplifying something and solving something? So if you can please pause the video now, I want you to write down what you think is correct and I will come back with my answers. So please pause now. So here's what I said for simplify versus solve. Now you might have had something different, and if you did, I would love to hear about it in class or during warm-ups. So for simplification, I said that it means you either eliminate or reduce, or in other words, you combine like terms, which I'm sure a lot of you are familiar with. Solving, on the other hand, you're either wanting to find the value of a variable, isolate a variable, which means your answer could maybe not be numerical. Maybe it's like something like y equals 2x. That's still solving. And it still does use simplifying. So I would say that solving definitely involves this, but simplifying does not necessarily involve solving. Moving onwards, another one I'd like you to pause and answer. What is the difference to you between an equation and an expression? So please write equation and expression and write down what you think is different. And again, I will be back with my answers. All right, I'm back. The difference to me between an expression and an equation is that an expression you cannot solve because it does not have an equal sign, but it definitely can be simplified if possible. An equation, on the other hand, can be solved because it does have an equal sign, and it also is possible that it could be simplified. So an expression, a main difference, if I had an expression like 2x plus 4, the only difference between expression and equation would be 2x plus 4 equals a number. So in this case, you could solve to get the x equals 1. Here, because there's no equal sign, we have to leave it as an expression. We cannot combine 2x and 4 because they are not like terms. The 4 would need an x to be combined with 2x. Last piece of vocabulary before we get into the word problems portion is what do each of these 4 words mean to you mathematically? Product, sum, difference, and quotient. And I would like you to do 2 things. I would like you to write the word that you think of first when it comes to all 4 of these vocabularies, and then I would also like you to write synonyms for each word. If you think about, for instance, let's start off. Product, when I see the word product, I think about multiplication. And just to start you off, another word for multiplication could be times. So I would like you to figure out more words that are synonyms with product and also write definitions for the rest of these. So again, I'm going to pause. Please at this time pause with me and write down what you think is correct, and you'll check with me when you get back. So please pause now. All right, guys, so back in what I have so far is I started off each of these with the result of 2 or more numbers using multiplication. The result of 2 or more numbers for sum means addition. The result of 2 or more numbers with difference really means subtraction, and for quotient it means division. So first, please make sure you have all of these in green, or you agree with me with those in green. Now, during the time when I was writing these, I also changed my color for these synonyms. So far we wrote times. Other things for product that I thought of was percent of, comes up quite a bit, as well as just of. You're going to find that whenever you see the word of, and this comes up multiple times, please think of it as multiplication. For some synonyms of addition would be increased by, more than, and even plus. And again, if you have any more that I didn't write down, please let me know. I'd be happy to hear about it. Difference subtraction. Other synonyms could be minus, reduced by, less than. And last but not least, division. You could say, I know it's somewhat the same thing, but you could say divided by. You could say ratio, which is very popular because remember from earlier videos, quotient written as a fraction, ratio written as a fraction, and also per. Per is a good synonym for quotient, like miles per hour, for instance. That is a comparison of two values in fraction form. Okay, so now that we have some of this vocabulary down, let's go through some descriptions, especially of expressions. Write a verbal description of the algebraic expression without using the variable. What that means is instead of x, you can say a number. So anytime you see a variable, just say a number instead. And again, instead of jumping right into it, I do want you to think about these first. So please try all three of these, write them however you think that they're going to sound. So this one, you could say something like a number plus 4, and write down as many as you think. When you come back, I will have these written out because it's going to take me a little while to write them. So please write down what you think is correct now. All right, guys, so feel free to pause the video whenever you'd like to write some of these down. For the first one, x plus 4, I wrote down 3 options. You could say a number plus 4. You could say the sum of a number and 4. You could even say 4 more than a number. And of course, there's probably more options, but those are a good 3 to start with. For the next option, I said possibly 4 less than a number, all divided by 5, could work. The good thing about these problems is you have some freedom because there's a lot of different answers. Another option is the quotient or the division of the difference between a number and 4 and the number 5. The green is also a possibility. Also, you could say, let me scroll down a little bit, the difference of a number and 4 divided by 5. That also could work. I would say that the green is probably the wordiest, but it is using the vocabulary that is sometimes not used as much, which is why I put it there. Last but not least, this one again has multiple options, both of them being pretty wordy. So the first one I said was the product or the multiplication of 12 and a number times the difference of the same number and 5. That could work. And again, of course, you might have something different than me. In green, I wrote the product of 12 times a number and 5 less than the number. Again, if you had something different, I would love to hear about it in class tomorrow. I'm sure you can ask any of your teachers tomorrow in class about these problems. So please pause the video now if you'd like to write any of this down. The next problems are looking at expressions or verbal expressions and writing it down also as an algebraic expression instead. So these I'd like to go through with you. First, we want to write down an expression for the sum of 2 consecutive natural numbers. Now, natural numbers, remember, are the counting numbers. So 1, 2, 3, 4, 5, 6, 7, 8. And we would like to find the sum or the addition of them. So let's say that x represents the first number, or the first natural number. So we're going to be adding the first natural number to something else. Now, the word consecutive means the number directly next to on the number line. So if x is the first number, it would make sense to me that x plus 1 would have to be the second number because it is directly next to it on the number line. So if we were going to create a complete expression, the sum would be the first number plus the second number, which could be simplified to be 2x plus 1. Either of these answers would work because I didn't tell you to simplify, but I would say simplifying is usually a good idea. B, write an expression for the distance traveled in t hours by a car traveling at 50 miles per hour. Well, as seen in previous videos, when I see distance in a time, I think about distance equals rate times time. But the reason I'm not going to do equals is because we want an expression and not an equation. So if I just want to represent the distance, I know that I'm doing rate times time. So my rate is 50 miles an hour, and my time I don't know. So we could just say that the expression could be 50t. The next one, part C, want the perimeter of a rectangle with a width of x. So I'm a very visual person, so let me draw a rectangle. Has a width of x. Remember, opposite sides are congruent, so we have x here. And it has a length that is twice the width. So twice means, or twice to me means multiplication. So I would say that the length is 2x. So this one is also 2x. So the perimeter of this entire shape, perimeter is all the way around the outside. So we'd be adding all the sides. The perimeter, x plus 2x plus x plus 2x. So because it's an expression, not an equation, I'm going to get rid of p equals, and the expression that will represent, if I combine like terms, would be 6x. Last but not least on this page, we want an expression that's 30% of to me, remember from earlier, means multiplication of the list price. Now, in order for these to be more like terms, if we wanted to change this to a decimal, we move the decimal over twice to the left, so the expression would be 0.30L. Now on to the modeling, on to writing an equation and solving. Here is the first one. One positive number is, whenever I see the word is in a word problem, I think about equals another number. So if we start there, I have two unknown variables, and it looks like I'm going to have one number that's much larger than the other. So let me just artificially call x the smaller number and y the larger number. So based on the first sentence, one positive number is 5 times another number. So my larger number is 5 times bigger than my smaller number. So there's equation 1. Now I know I need a second equation because I have two lovely variables. The second equation is going to come from here. The difference, or subtraction, between the two numbers is 148. Now it makes sense to me that we're going to take larger number minus smaller. So larger minus smaller equals 148. Now I need to solve the system with either graphing, substitution, or elimination. Because I notice that the y is already solved for, let's do a little substitution, shall we? Where we plug 5x in here. So we'd have 5x minus x equals 148. 4x equals 148. If I divide by 4, I get 37. Then if I plug x back in here, multiply that by 5, I get that my y value is 185. So here are my two numbers. Next one. 432 is, so if I'm going to write this as an equation, 432 equals what percent, I don't know percent, times 1600. So if my goal is to get the percent by itself, I'm going to divide both sides by 1600. Then I would get x percent equals, if I plug this into my calculator, this divided by this, I would get 0.27, but remember the problem is not asking for a decimal, it's asking for a percent. So the answer is really 27%. So 432 is 27% of 1600. So this last problem, you're talking about a swimming pool, and it has been discounted 16.5%, and they didn't give you the original price, but they give you the sale price, and we're trying to find the original. So to me, if my discount is 16.5%, that means I'm actually paying 83.5%, which would be 0.835 as a decimal. So if I call x my original price, is which I'm looking for, and I say that I paid 83.5% of times the original price, that would have to equal the discount. If I divide by 0.835, my answer is $1,450.